Welcome. In this video, we are going to take a look at problem 41 from chapter 29 of College Physics 2E by OpenStax. In this problem, we have a gamma ray photon. We know its momentum and we need to calculate its wavelength, and then we need to calculate its energy in mega electron volts. So let's start with what we know. And we know the momentum P is 8.00 times 10 to the minus 21 kilogram meters per second. We need to find its wavelength, and we also need to find its energy. Okay, so we start with the wavelength. And we can use the de Broglie wavelength. This works for matter and for photons, and it is that momentum is h over lambda. So lambda p is equal to h. And so lambda is h divided by momentum. Okay, h is Planck's constant. It is 6.626 times 10 to the minus 34 joules times seconds. Divide by the momentum, which is 8.00 times 10 to the minus 21 kilogram meters per second. This gives us a wavelength of 8.28 times 10 to the minus 14 meters. We can check the units. We have joules times seconds divided by kilogram times meters per second. Okay, so a joule is a Newton meter times the second. Then we are dividing by kilograms times meters, and then the seconds goes upstairs, so the seconds become squared. We can cancel the meters. We can rewrite the Newton as a kilogram meter per second squared. Then we have seconds and kilograms left over from before. And then we can cancel the kilograms and the seconds squared. And we are left with meters. Okay, so there's part A. Part B is the energy. Okay, we can use momentum is energy divided by speed of light. So that energy is momentum times the speed of light. Okay, the momentum we found. We found the wavelength. We were given the momentum of 8.00 times 10 to the minus 21 kilogram meters per second times the speed of light, 3 times 10 to the 8 meters per second. This gives us an energy of 2.40 times 10 to the minus 12. That will be in joules. We need to calculate this in mega electron volts. So let's convert it to electron volts. 1 electron volt is 1.60 times 10 to the minus 19 joules. And then 1 mega electron volt is 10 to the 6 electron volts. This gives us an energy of 15.0 mega electron volts. And that was what we needed to find. I hope this was helpful. Let me know in the comment section if you have any questions. Thank you for watching, and I'll see you in the next one.